Anomalies or counterexamples. In the 1960s, Thomas S. Kuhn wrote a book called The Structure of Scientific Revolutions. This work has become something of a modern classic, and you will hardly be able to find a book on the modern philosophy of science that does not deal with the ideas presented in that book, whether directly or indirectly. It is remarkably clearly written and is compelling in its presentation. I cannot say that I agree with every point that Kuhn makes in his work. Specifically, I feel that some of his conclusions are suspect, but the majority of his book deals with the distinction between what he calls normal science and revolutionary science, though it must be noted that a common critique of Kuhn's work is that his treatment makes the distinction between these two concepts sharper than they are in reality. However, especially as Kuhn's work was so groundbreaking, it could hardly have been otherwise. A brief summary is in order before we move on. Normal science is what scientists are engaged in most of the time. They operate within a particular paradigm of thought and practice with certain agreed-upon attitudes and concepts. These paradigms are comprehensive in the sense that questions that cannot be posed in terms of the reigning paradigm are simply not entertainable. They are not seen as being scientific questions. This paradigm is passed down from generation to generation, in the case of science, in the textbook tradition. Scientists spend the vast majority of their training learning a paradigm and indwelling it to the point where it plays a dominant role in the thought of the scientist. This is a great part of the reason why the natural sciences have tended to be far more unified than just about any other field, which does not share the same kind of textbook tradition. Normal science operates from within a particular paradigm and functions primarily after the fashion of problem solving. Certain problems arise in scientific investigation, and the scientist seeks to account for the empirical data within the terms of the paradigm. A good example of this is when scientists were working to fill out the periodic table of elements. If one found a hitherto unknown element that fit in where one would expect such an element to be on the table, it was grounds for celebration over the furthering of human knowledge, but few were surprised at such discoveries. The paradigm predicted it. There are times when, however, certain empirical phenomena do not submit themselves easily to the paradigm at hand. When a paradigm that has been so very fruitful has moments where it seems that it can no longer account for the certain data, what is the scientist to do? Ultimately, there are only two real responses that one can make. Either the data in question is an anomaly, something that seems to deviate from the account given and expected by the paradigm, but will ultimately be resolved either with further study or with very minor adjustments to the paradigm, or it is a counterexample. By counterexample is understood data that not only does not fit into the reigning paradigm, but cannot be fit in. Such data is not merely a puzzle to be solved, but a crisis that necessitates a scientific revolution and a paradigm shift. Revolutionary science takes place when the old paradigm no longer seems sufficient, and a new one needs to take its place. This change is often stalwartly resisted by the older generations of scientists who see the revolution as an abandonment of the tradition and therefore of science itself. A helpful example of this is the change in physics brought about by James Clerk Maxwell and his electromagnetic theories. Maxwell tried for years to explain electromagnetic phenomena in terms of Newtonian mechanics, where mass and distance were the only variables. Even in this failed pursuit, Maxwell developed partial differential equations, which have been so very helpful in subsequent physics. However, he eventually felt he needed to abandon Newton, or at least cease acknowledging the hegemony Newton had over physics, and developed what he called a dynamical theory of the electromagnetic field, which tried to explain the phenomena in terms of continuous fields of force. When he did so, his relative Lord Kelvin accused Maxwell of lapsing into mysticism. Above, I remarked that when an old paradigm is seen as to be no longer satisfactory, a new one must take its place. One might ask, why can't we just get rid of paradigms altogether and operate with paradigm-free science? This seems to be a noble goal, and one that always seems possible so long as paradigm-free science bears a remarkable resemblance to the current paradigm, but this is an impossible goal. The paradigm is the very framework of thought in which the scientist considers the data. There is no such thing, or at least no such language to describe, as theory-free and therefore paradigm-free data. For example, it seems self-evident to a modern scientist that oxygen in the air is why combustion can take place, but this was not always the opinion. Once it was believed that all combustible substances contained something called phlogiston, that was in addition to the pure substance. Phlogiston and oxygen are not simply two different ways of looking at the same thing, they're fundamentally incompatible understandings of what is now known as oxidation. However, regardless of whether one is operating with the phlogiston theory or the oxygen theory, there is always a theory, and one cannot pretend that there isn't one. At the end of the day, one might be able to describe the difference in whether a particular piece of data is an anomaly or a counterexample as a difference between dedication to the paradigm or dedication to the experience. If one is more dedicated to the paradigm than they are to the experience, they will tend to see the data in question as an anomaly. If they're more dedicated to the experience than to the paradigm, they will tend to see it as a counterexample. Given these two options, most people would find it, especially in America where we have something of an attenuated appreciation for history, silly to affirm the paradigm over and against the experience. After all, is not experience the really basic building block of science in the first place? However, before we become too hasty, let us suppose that an individual with a consumer-grade telescope calculated the locations of stars or planets to be different than the tradition predicts. Would we throw out the reigning paradigm because of this counterexample? Or would we not rather argue that the individual has likely made some error? We find that we are likely to make the same move even if it were a trained scientist working with professional-grade equipment. Indeed, the scientist herself would likely come to the same conclusion. To do otherwise would give far too much credence to a particular experiment rather than the long-standing tradition. It turns out that this is really the only course of action, and one should not too hastily condemn scientists for doing this. After all, the likelihood that such conflicting data will be revealed to be attributable to human error is quite high, as one could imagine. In order to not be derailed by every whim or flight of fancy that is put forward, there has to be some kind of conservative predisposition among scientists, a hermeneutic of trust, to use such language, that enables normal science to keep making advances. If science were to treat every challenge as a real threat and a real need to utterly rethink all of science, it would look much more like modern philosophy, with numerous schools of thought that never seem to go away and never seem to make real progress. The question remains, why does one scientist view a particular phenomenon as an anomaly and another scientist views it as a counterexample? One is not necessarily being any more scientific than the other. Both are operating within the patterns established by scientific practice over the last several hundred years. The difference is that the former scientist is engaged in normal science, while the latter is engaged in revolutionary science. The former is likely to be called conservative and stubborn, while the latter is likely to be accused of abandoning science and reason. Science and reason being defined, of course, in terms of the previous paradigm. History has vindicated Maxwell over Kelvin in their disagreement, but that does not mean that Kelvin was a lesser scientist. Indeed, he made many significant contributions and was perhaps one of the most brilliant scientists of his day. An appeal made purely to science will not decide between normal science and revolutionary science. It is another extra scientific criterion that decides between them. Now, it needs to be made clear that it is entirely possible that either one of these scientists might be wrong. After all, it's clear that there have been many scientific revolutions, such as initiated by Copernicus, Newton, Dalton, Einstein, and others. Clearly, it is possible for the conservatives to be wrong in holding so tenaciously to their systems. However, it's equally likely, if not more likely, that the would-be revolutionaries turn out to be sadly mistaken. Such failed scientific revolutions are less noteworthy since they were wrong and are, therefore, not preserved in the textbook tradition. It does not change the fact, however, that for every successful scientific revolution, there are several would-be insights that turn out to be far less significant than their originators hoped. The trick is that it's not possible to decide ahead of time which side will be right and which is mistaken. Only time will tell. However, though one must always remember that their views might very well be wrong in spite of their care and exactitude, if we hope for the truth to be discovered, scientists must proceed in passionate commitment to their paradigm. If one is ambivalent toward their paradigm, they will not take it seriously enough to really explore it. This might seem counterproductive, and it's true that such commitment means that it often takes the whole old generation of scientists to die off for a new generation to be able to decide between the two competing paradigms. But the point is that unlike other fields, reigning paradigms actually do emerge in science. Decisions are actually made. The fact that we as a society actually believe this is manifested by the way our courts operate. The jury is called to be impartial, to be as free from presuppositions and preconceived convictions as possible at the start of the trial. The same is true of the judge. However, the lawyers are not expected to share in this neutrality. In fact, within the context of the trial, they are ordered by the state to have a specific agenda that must rule their whole approach to the case. One lawyer is to be passionately committed to demonstrating and defending the innocence of their client. The other is to be passionately committed to demonstrating their guilt. This is incredibly important. Only someone who is so deeply committed to a position, sometimes even against what circumstances seem to warrant, will be able to find all the evidence for their particular side. Both the defense and the prosecution need this kind of efficiency, for it's only in such a way that all the facts come to the surface. To blend the courtroom analogy with our scientific terminology, we could say that the prosecution is attempting to show that the reigning paradigm is insufficient, while the defense is hoping to show that it is sufficient, at least for now. That is to say, the prosecution is representative of revolutionary science, while the defense is representative of normal science. In the context of this courtroom drama, the defense wants to show that every single phenomenon that does not fit into their paradigm should be understood as an anomaly that will eventually be explained away as being insignificant, or at most being something that will require minor adjustments to the paradigm. The prosecution wants to show that every single such phenomenon is a counterexample that falsifies and overthrows the paradigm. It is only when both sides, who are deeply committed to their positions, have done all this work that a neutral third party can even begin to make a fair choice. As you may have imagined, I think that this has an impact on how we approach religious convictions just as much as how we approach scientific convictions. Some people who are radically anti-evolution in all its forms will point out every tiny example they can find where Darwinian evolution, at least as they understand it, falls short and provides an inadequate explanation. Those who make this kind of critique are often not exactly well versed as to the actual practice of science. More strict Darwinians often make the point that their paradigm, though they do not tend to use that language, is fantastically successful in explaining a huge amount of phenomena, and that a single footprint here or specimen there does not and cannot overturn it. This is true. However, just as it is foolish to assume that every deviation from the theory is a counterexample, it is equally foolish to assume that every deviation from the theory is merely an anomaly. The fact of the matter is that within the scientific community, the decision between anomaly and counterexample is not based on science or empirically verifiable standards, but is a decision made outside of science and applied to it. If someone wishes to demonstrate that these deviations are counterexamples, they must do so on a level of rigor similar to those who instigated other scientific revolutions throughout history. Anyone who is unwilling to engage in science, in this case biology, for its own sake and on its own terms, in this way disqualifies themselves from having their voice heard, as they do not take the subject they wish to critique seriously. To flip things around, there are many atheists who will take everything that Christian faith asserts that seems to them not to fit into their paradigm as counterexamples that falsify and overthrow Christian faith. Of course, just as it would be scientifically irresponsible to take every initially inexplicable fossil or specimen as a conclusive proof that Darwinian biology is utterly wrong, it is equally irresponsible to make such a move when dealing with Christian faith. Any critique of the Christian tradition that is utterly unwilling to take that tradition seriously and on its own terms ought to be disqualified from having their voices heard, just as in the case with natural science. However, that does not tend to be the case in contemporary discourse. In the debate between Alistair McGrath and Richard Dawkins, Dawkins makes several sweeping generalizations about the Christian conception of God. McGrath makes the charge that Dawkins is appallingly ignorant of Christian theology. However, instead of being ashamed of his ignorance or even slightly apologetic, Dawkins argued that his ignorance of Christian theology is no different or worse than McGrath's ignorance of fairyology. It's a non-subject, not worthy of being dignified with study. But here's the difference. McGrath has published no books on the folly of believing in fairies, while Dawkins has published more than one on the folly of theism. Someone like Dawkins insists that his paradigm be respected, but feels no similar compulsion toward other paradigms. Perhaps he is unaware that he even has a paradigm, and that it is this ignorance that leads him to consider it to be normative over others. The point is that we need to recognize that there are aspects, even among the most dedicated and brilliant scientists, where we are deeply formed by non-scientific, non-rigorous influences. It is true that a Christian theologian or pastor has a lot of personal reasons for affirming Christian faith, for if they were to reject it, they would lose their job. However, it's equally true that someone like Richard Dawkins has a strong non-scientific impetus to never accept Christian faith, for he would radically be rejected by his community. I know an atheist mathematician who, when I asked him whether he thought the universe was elliptical or hyperbolic, being different forms of non-Euclidean geometry, responded elliptical. I asked him if there was any hard evidence for this, to which he replied yes, but then made bodily gestures that made it clear that there was no such hard evidence, and he knew it, and was taking a stand anyway. I understand that his gesture was intended to communicate all of this as well, as he has quite a good sense of humor. I was greatly intrigued by his response because it seemed to me that his deep ultimate convictions pushed him into one interpretation of the universe in precisely the same way that mine pushed me to the opposite conclusion. Neither of us have science on our side, for the science is inconclusive. But that also means that neither of us has set ourselves up against science. We make decisions all the time, for we have to make them, whether we want to or not. These decisions will, in one way or another, depend on whether we interpret phenomena as anomalies of or counterexamples to particular paradigms, and there's no way to know ahead of time whether we are right or wrong. We must learn to recognize this and understand that we might have deeper influences than we realize.